Namaskar dosto. Welcome to Toxicology on Board channel. Today we'll discuss about question number 15, uh, ethylene glycol, diethylene glycol, propylene glycol, glycol ether, and toxicity and antidotes. So this question was taken from DABT recertification question 2001. Okay, through this video we'll learn about various glycols and its toxicity. In case of DABT exam, solvent toxicology is very important topic. In that solvent, maybe it is chapter 24 in the case of Clason's textbook. uh, See, various solvents are there, alcohols are there, benzene, toluene, kerosene, and glycol. So all various solvents are there which are widely used in the industrial pharmaceutical industry or other industries. Okay, so in that, glycols also has very wide application. So today in this video we'll be learning about ethylene glycol. Let's see another glycols also. Let's directly go to the question. Question is, ethylene glycol is more toxic to human than to other animal species. Option A. Option B is may produce calcium oxalate bladder stones. Option C, may cause severe injury to renal tubules. Option D, toxicity may be treated with ethanol. Option E, all of the above. So let's see what is the right answer. The right answer is option E, all of the above. Okay. So as I said, through this video we will be learning about solvents in the glycols and glycol ether toxicity, its adverse effects, antidotes, all these things we'll be learning in this video. So let's directly understand what is ethylene glycol. Ethylene glycol often produces kidney damage by production of calcium oxalate crystals in the kidney. We have seen in our previous videos also how oxalate crystals are formed because of ethylene glycol. They get deposited in the kidney, particularly in the proximal convoluted tubule. Okay, kidney stones will be formed. Okay, the next, acute overdose symptoms of this ethylene glycol is similar to that of methanol. So whenever you are reading ethylene glycol, no, you also have to read alcohol toxicity. So both glycol toxicity and alcohol toxicity go together. Okay. And acidosis is common for both methanol toxicity as well as ethylene glycol toxicity. So let's see the metabolism, how this ethylene glycol get metabolized in our body. Alcohol dehydrogenase, this is very important enzyme, mediates the conversion from ethylene glycol to glycolic acid. So this is our solvent ethylene glycol. In our body, it is metabolized by the enzyme alcohol dehydrogenase to glycoaldehyde. Aldehyde is formed. Further, this aldehyde, specific aldehyde, is metabolized by the enzyme aldehyde dehydrogenase to glycolic acid, also known as glycolate. This glycolic acid is further metabolized to glyoxylic acid and further metabolized in our body to form oxalic acid, which reacts with calcium to form calcium oxalate. This calcium oxalate is the thing which is forming crystals in the kidney and causing kidney toxicity. Okay, ethanol is much better substrate for alcohol dehydrogenase than is ethylene glycol. As I said, whenever you are reading about ethylene glycol toxicity, also you have to read about alcohol toxicity like methanol as well as ethanol, because both methanol and ethanol are also metabolized by the enzyme alcohol dehydrogenase. For example, there is a patient who comes to emergency department and he was identified to be having alcohol poisoning. Then you have that physician has to the physician treats that particular patient with glycol poisoning by giving ethanol, because ethanol this act as a competitive inhibitors with ethylene glycol. The thing is that alcohol dehydrogenase is a common enzyme. It will metabolize both ethylene glycol and ethanol. If both the solvents are there in your body, then alcohol dehydrogenase has more favor towards ethanol rather than ethylene glycol. As a result, there will be no formation of these metabolites, particularly toxic metabolite, oxalic acid and calcium oxalate. As a result, you can treat ethylene glycol poisoning with ethanol. Okay, main mechanism here is competitive inhibition. Okay, this you will understand when you read about agonist, antagonist, antagonism, inverse agonism. All these things you will be reading in case of principles of pharmacology as well well as principles of toxicology. In those chapters you will be reading. Okay, apart from ethanol, you can also treat a patient with ethylene glycol poisoning with another chemical, that is fomepizole antizole. Okay, because fomepizole also same mechanism, it acts as a competitive inhibitor. So it is also metabolized by alcohol dehydrogenase, so there will be no longer enzyme available in our body to metabolize ethylene glycol. As a result, there is no formation of this toxic metabolites. Okay, so ethanol is an antidote for ethylene glycol poisoning. So few questions you will come across such things. Okay, antidotes. Next in our question we have in our topic we have another solvent, diethylene glycol. Okay, so diethylene glycol, also known as DEG, it is converted to ethylene glycol. So once you read about ethylene glycol, the same adverse effects or same symptoms, everything will be applicable to diethylene glycol. So toxicity is therefore similar to ethylene glycol. Next, DEG is a sweet tasting, colorless, non-odoriferous and hygroscopic liquid. This is important. Sweet tasting. Because of it, sweet taste also, diethylene glycol is used as a solvent. The DEG can be used as a main component in antifreeze and braking fluid. So in case of antifreeze, ethylene glycol, diethylene glycol is there, and braking fluid in your cars also you will use DEG. Will come across. DEG can be used and found in making of cigarettes. So this is another reason you should never smoke. Okay. Next, DEG is metabolized in the liver via the same NAD dependent pathway ethanol. As I said, both DEG as well ethanol also metabolized by the same enzyme alcohol dehydrogenase, and it forms what DEG is later oxidized to 2-hydroxy ethoxy acetaldehyde. Okay, by NAD dependent alcohol dehydrogenase. This is a common enzyme. DEG is later metabolized even further to 2-hydroxy ethoxy acetic acid. Okay, HEAA by aldehyde dehydrogenase. Okay, so important thing that we need to learn from this about diethylene glycol is the first mass poisoning was the sulfanilamide messenger disaster which occurred in United States in 1937. So sulfanilamide elixir disaster by itself is another very big topic. Very quickly I try to give some important points. So this is, you can see from the FDA, this particular notice there that you can go and read in FDA website about this disaster. And this is the thing, the notification which was given at that time in 1937 because of the recall of this particular drug. Sulfonylurea antibiotic, it has an antibacterial property. It was widely used in 1930s. So earlier this particular drug was available only in powdered and tablet form. So there was a very big necessity to have this particular drug in solvent form. So this particular company, I do not want to name the company name. So they wanted to prepare a solvent preparation. So that formulation scientists started trying to dissolve the sulfanilamide into various solvents. Okay, but they found that it is highly insoluble, and finally they found that it was soluble in diethyl glycol. Okay, and another biggest advantage of using DEG was because of its sweet tasting. Sulfanilamide drug as such, it was bitter in taste, not palatable for the children formulation. So by preparing for elixir or a solution in DEG, it enhances the sweet properties also. Okay, but once it started coming into the market, they found there was more than hundreds of deaths has happened because of because diethylene glycol as such, it causes kidney toxicity and other toxicities. So this about this disaster you can go back and read in detail. Because of this particular incident now, that led to in 1938 for the formation of Food Drugs and Cosmetic Act, because before that there was no necessity to conduct toxicology test or safety test for the drug formulations. After this incident, the I think that at that time President Roosevelt was there. The Food Drug and Cosmetic Act came into picture in 1938 because of one of the biggest reason is this one, and second reason is thalidomide tragedy. Okay, next we learn about third solvent, that is propylene glycol. Propylene glycol is much less toxic than ethylene glycol or diethylene glycol. Okay, compared to other two glycols, this is less toxic. It doesn't have any system or organ toxicity. Used in cosmetics and pharmaceutical preparations, propylene glycol is metabolized by the enzyme alcohol dehydrogenase based mechanism to lactic acid as well as pyruvate. Okay, this PEG is recognized as GRAS by the FDA. So learn about generally regarded as safe. So there are there are excipients which are used in pharmaceuticals, which FDA states them as GRAS. So go and read about GRAS. Next we'll learn about glycol ethers. They cause testicular damage, teratogenicity as well as hematological effects, particularly hemolytic anemia. From the previous videos also I told you, please learn about types of anemia. One or two questions definitely will get based on anemia. Ethylene glycol monomethyl ether EGME is toxic to human, animals and causing reproductive, developmental and hematopoietic issues. Very important, EGME, DGME, these glycol ethers, till today they are used in pharmaceuticals preparations. So there will be kidney toxicity will there. Recently you might have come across one case in case of Africa where the children were died because of this. These syrups, cough syrups, they contained these glycols, because of which there was kidney toxicity. So read about this. This is only 1 to 2 years back only, this incident. Okay, 4-methyl pyrazole, fomepizole inhibits alcohol dehydrogenase, which decreases the embryo toxicity of EGME. So whenever there is EGME toxic, better you are administered 4-methyl pyrazole, which act as an antidote. Okay, propylene glycol ether is safe. As I said, PG is given GRA status by the FDA. So we are done with the three the glycols. So today we have learned about ethylene glycol, diethylene glycol, and propylene glycol. I kept this slide because I wanted you people to compare all the three mechanisms together. So here calcium oxalate is forming. What is happening in the case of DEG? Once it is formed ethylene glycol, the rest of the metabolism will remain same. And coming to propylene glycol, it is forming lactate as a pyruvate, which are less toxic metabolites when compared to other two glycols. It is completely safe, PEG. Okay, this is taken from Clayson page. I've given page numbers also about the ethylene glycol, how it is causing, how it is converted by alcohol dehydrogenase to glycoldehyde, then glyoxylic acid, glycolic acid, then oxalic acid. This oxalic acid reacts with calcium to form calcium oxalate. This which you can identify. Calcium oxalate crystals are formed and they can identify in the urine. So this you please go back and read the textbook. Okay, apart from this you also read under that chapter, I think under solvent chapter only, you read about ethylene glycol, diethylene glycol, propylene glycol, glycol ethers, how they are causing reproductive toxicity, developmental toxicity, hematotoxicity, immunotoxicity as well as carcinogenicity. Okay, I also included another picture from the Clayson only, page 1233, metabolism of glycol ethers. Okay, please this go and read about this particular picture also in detail. Mostly what is happening in this case is that ethylene glycol is converted when it is combined with alcohol aldehyde. These alkyl groups are replaced either with methoxy, ethanol, or here they have given CCH3 or CH2, CH3. Okay, how these toxic metabolites are formed by act by various enzymes in our body, that you can read. Okay, so thank you so much. Hope this video was useful for you. Be curious. For any questions, please comment or write a mail to arya.priyanka18@gmail.com. Like, subscribe, and follow my YouTube channel, Toxicology on Board. All the best for your exam. Thank you.